Hello and welcome to a course on exam techniques for Grade 12 Mathematics. Thank you for the opportunity to share knowledge on terms of algebra and how they produce a solution in mathematics. Here, the focus is on how to use the Bodmas rule to simplify various quadratic or exponential expressions into their standard forms. Ultimately, singular values of a mathematical expression are obtained as solutions to a standard form. Now, let us see how all this comes together in a typical exam session. Suppose an equation is given by a product of x plus 5 and x minus 2 equals 0. To solve for x, note that the factors of the equation are given by x plus 5 and x minus 2. Therefore, x equals negative 5 or x equals 2. Suppose a quadratic equation is given by 5x squared plus 2 equals negative 9x. To solve for x, first standardize the equation such that 5x plus 9x plus 2 equals 0. Notice that the roots of the equations are irrational and hence can be obtained using a quadratic formula. This formula can be found at the back of the question paper on the day of the exam. First, note that a equals positive 5, then b equals positive 9, and then c equals positive 2. Substitute these values into the formula as shown in this slide. Use a pocket calculator to evaluate the formula for both positive and negative square roots, respectively. Then, x equals negative 0.26 or x equals negative 1.54. Suppose a quadratic equation is given by the expression 8x squared greater than 2x. To solve for x, it is necessary to obtain both y and x intercepts. For x-intercept, assume equality and use a standard approach to a quadratic equation. The standard equation is given by 8x squared minus 2x equals 0. Take out the common factor of 2x. Then equation is factorized by 2x or 4x minus 1. Therefore, x equals 0 or x equals 1/4. Notice that the intercept of y equals x when x equals 0. Further note that the expression of 8x squared minus 2x must be greater than 0. Always, this is defined only in the interval such that x less than 0 and x greater than 1/4. Suppose you are given an exponential equation defined by 2 times base 2 exponent 2x minus 9 times base 2x plus 4 equals 0. To solve for x, first note that base 2 exponent 2x equals base 2 exponent x all raised by 2. So if k equals base 2x, the equation simplifies to a quadratic equation. Therefore, the equation is given by 2k squared minus 9k plus 4 equals 0. This is factorized by 2k plus 1 or k minus 4. Therefore, 2k equals negative 1 or k equals 4. Note that only k equals 4 is a valid solution. Therefore, base 2 exponent x equals base 2 exponent 2. Since the base is the same, exponents are equal, such that x equals 2. Suppose the equation is given by square root of sum of square root of 1 over x plus 2 equals 1 over square root of x. To solve for x, it is necessary to first naturalize all exponents, that is, remove all square roots in the given expression. First, note that square root of 1 over x equals base 1 over x exponent 1 over 2. By simplification, this is equal to 1 over square root of x. If k equals 1 over square root of x, the given expression simplifies to square root of sum of k plus 2 equals k. Using the BODMAS rule, this is simplified to k plus 2 equals k squared. In order, this is k squared minus k minus 2 equals 0. This standard equation is factorized by k minus 2 or k plus 1. Therefore, k equals either 2 or negative 1. Note that only k equals 2 is valid. Therefore, 1 over square root of x equals 2. Furthermore, this simplifies to base x exponent negative 1/2 equals 2. Square both sides so that x equals base 2 exponent negative 2. Therefore, x simply equals 1 over 4. Suppose simultaneous equations of x and y are defined such that the first equation is defined by x is the sum of 2 and y. The second equation is defined by 5 times the product of x and y is 6 more than the square of x. Substitute equation 1 into equation 2 as shown in this slide. Simplify using BODMAS rule so that a standard quadratic equation is given by 2y squared minus 3y minus 5 equals 0. This is factorized by 2y minus 5 or y plus 1. Therefore, y equals 5 over 2 or y equals negative 1. Substitute values of y into equation 1 such that when y equals negative 1, x equals 1. When y equals 5 over 2, x equals 9 over 2. I hope you enjoyed my thoughts on exam techniques for mathematics questions on algebra. Please subscribe to our channel, like this video for more likewise, and share it with like-minded friends. See you next time!